So in this video, we're going to talk about actually constructing some orbifolds, because the idea is that you could take one of these planes and fold it so that you have exactly one copy, and different things will happen depending upon the pattern. So we're going to take some of the ones we've already worked with and work with you on them.
Of course, we can't fold it infinitely, so the first thing we're going to do is actually cut out a finite region, but we could imagine folding the rest of it into those same spots. So we're going to start with the star 333 pattern, and we're going to start by cutting out just a few copies of the pattern.
Okay.
So I'm just going to cut out 4 copies of the pattern here, of the fundamental region that we found earlier. And once I have my 4 copies, I'm just going to fold and fold and fold. And I could imagine doing that with all of the infinite number of copies in the plane. And that right there is my whole pattern. That is my orbifold. Now this one, it actually is exactly the same on both sides. So it really is just one surface, and this is just sort of the back of it, but there really is only one copy. One way to think of this is if we had a two-dimensional ant crawling around on our orbifold, that two-dimensional ant wouldn't be able to tell the difference between the orbifold and the original repeating pattern. When they came to a mirror line, they would just keep going and experience the same pattern again. The star 333 pattern just turned out to be a triangle. It's a little bit trickier to get the 333 pattern because in this case we just folded along mirror lines, but this time we don't have any mirror lines. So we're going to start by marking some centers, and we still need to find part of the design to cut out. So I've outlined a hexagon plus one additional triangle, and this will give us enough of the pattern to see what's happening here. Rather than folding up, it's almost like this pattern is sort of all wrapped up, and we'll see what we mean in just a second. When we have a gyration point, a center of rotation that's not intersecting mirror lines, we're going to call it a cone point, and you're going to see why in just a second, because as we try to wrap the figure back on itself, it sort of forms a cone. Now in this case, what we get is actually a triangle again, but this time the two sides of the triangle are different. And our two-dimensional ant, if it crawled to the edge and kept going, it would see a new design on the other side, but then if it went around a second time, it would see the same design again. So in the case of this one, it's really only one-sided. And these are actually edges. And these are corner points. Here, these are actually cone points. And as the ant travels around, they have to go around a whole time before they see the same pattern again. So for the orbifold of this one, 4 star 2, we're really going to start to see a more interesting shape, and we can also really start to see the difference between a corner point and a cone point. And we're going to see why we only write the 4 once and the 2 once. Even though it looks like we have 4 centers of rotation here, we're going to see that they actually all converge on the same point. So just like we did with the star 333, we can fold the whole thing up so that we're left with just this copy and everything else is folded onto that. So I'm going to cut out that one little part. Now I need to cut into the center so that I can start forming my cone point. I'm going to twist it into a tighter and tighter cone until all 4 of those points converge onto one. And now we can clearly see why that 4 is a cone point. And it is only 90 degrees around here. And there's only one copy of the design around that point. So we'll notice now that all 4 of those order 2 rotation points all converged on this same point, and they all became the same point on our orbifold. And our mirror became an edge. We're starting to see how the symbols in the orbifold signature correspond precisely to the features of the orbifolds. So in this case, we have 1 edge and 3 corner points where we had intersecting mirror lines. And the signature was star 333, the star representing an edge and each 3 representing a corner point. For 333, we actually have no edge, and each one of these is actually a cone point, but there are 3 cone points. For 4 star 2, we have 1 cone point, 1 corner point, and 1 edge. We're going to look at star star now, and what we're going to expect to see is 2 edges. So now I've folded it so that we have the same thing on both sides. We can imagine folding infinitely until we're just down to 1 strip, and then roll it up until there's only 1 copy. Looks like we have it. And as we can see, this is an annulus that has an edge here and an edge here, but no cone points and no corners. The last one we're going to look at is the star X signature. And in this case, we've given you the one with the star X signature stretched out so that you can form it into its orbifold. We've already seen that the blue numbers represent cone points, that the red numbers represent corner points, and that the star represents an edge. So you may be asking yourself, what does the X represent? Well, we'll see here that the X really represents a change in topology. So the star X pattern, we expect to see 1 edge and then something else happen. So we're going to cut that out and see what we can do. So I've folded along all the mirror lines, so I have a single but infinite copy of it. But the pattern's repeated in this dimension. Unlike before, I can't wrap it onto itself by going like this. I have to add a twist to it and wrap it into a Mobius strip. Closer. All right, it took a little work, but now I have just 1 copy of the pattern, and it actually only has a single edge, which is what we expected. If you follow this edge all the way around, you'll come back to the same place, which is why it's a star, and the X represents a twist.
So this kind of brings to an end what we were going to do with the orbifolds, but we hope that you'll look at handout 6 with a whole list of them and try some of the other ones. There's some really interesting ones.
The one that we know you can't do is the XX. So you can sort of imagine we looked at star X and it ended up being a Mobius strip, and the XX ends up being a Klein bottle, which you can't do in the 3-dimensional world that we live in. There are a couple other ones that are difficult, and one that we aren't sure what it is.
Okay.
So in the next video, we're going to talk about the cost of an orbifold signature and how to calculate it.